In this video, I just wanted to go over a few problems on worksheet 7 about inverse trig functions that your classmates picked out as ones that might be helpful to go over. So in number 9, and in all these problems, it asks you to solve each equation for theta between 0 and 360, which basically just means anywhere in the first rotation around the circle. So in this first problem, where you have sine of theta equals -1, we're looking for the angle that gives us sine as -1. Now remember, if we have a point xy, x is cosine of theta, and y is sine of theta. So for this one, what we're asking is, where is there a y value? -1 on this circle. So if we think about our unit circle, oh, that was a horrible circle, there we go. And we think, where is y -1? Well, that happens down here at this point, which is 0, -1. That point, if we think about 0, 90, 180, 270, it only happens one time. That happens at 270 degrees. So theta is 270 degrees. So these problems, you want to remember your quadrantals. So go back and look at your notes about quadrantals. For any time you see something with 0, 1, -1, or 1 for sine and cosine, it's probably one of these 4 spots. Now this next one has 0 equals tangent of theta. So if you look at your chart, you don't see any times when theta is 0. But think back to your quadrantals again. So here, what we're going to do is think about these 4 points. So this first one is 1, 0. Here's 0, 1. Here's -1, 0. And here's 0, -1. Now, if you remember, tangent of theta is sine over cosine, which is y over x. So for each of these points x, y, let's figure out what tangent is. Well, here tangent of theta is 0 over 1, which is 0. So here's one time where it works. Let's try this one. Here, tangent of theta is 1 divided by 0, which is undefined. Here, tangent of theta is 0 over -1, which is 0. So again, this point works. And last up, we have tangent of theta is -1 divided by 0, which again is undefined because you can't divide by 0. So we realize we have 2 points here and here where tangent of theta is equal to 0. So those angles are 0 degrees or 180 degrees. The next problem I was asked for was number 13. So this is a pretty tricky one. But think about how cosine is the x value. Square root of 3 is about maybe like 1.7. Let's look at our unit circle. So if cosine's the x value, way over here is 1. Here is -1. And what they want to know is an angle that's going to give me an x value that's about 1.7. Well, if I look at 1.7 here, there's no values. So the reason this is no solution is because sine and cosine can only be between -1 and 1. So this was a tricky problem. But if you look at the unit circle, that kind of makes sense because we're kind of bound by -1, 1, 1, and -1. So there's never a time when we're going to be greater than 1 or less than -1. So that one was a little bit of a trick. In number 14, we want to know when cosine of theta is -1. So if I see a negative one, I want to kind of think about quadrantals. And remember, cosine is our x value. So where on this circle is x, -1? Well, that only happens right here, because this is the point -1, here's the point 1 for x. So our answer for this one is just that point right there, which is theta is 180 degrees. In this next problem, 17, we want to know when sine is 0. So we want to know when is the y value 0. If we look at our unit circle again, we know here's the point 1, 0, and here's the point -1, 0. So look, our y value is 0 at these 2 points. Those 2 points are 0 degrees or 180 degrees. And then we get into these problems that are a little bit trickier, because now we have to try to simplify first. So just like we did with certain absolute value problems, you kind of want to put a box around the sine of theta, and you want to isolate it first, or get it alone first on its one side. So right now, there's this 1 being added to it, and I want to get rid of that. To undo addition, I'm going to subtract. So I'm going to subtract 1 from this side and subtract 1 from this side. Now this is where you have to be careful. We have sine of theta equals 2 plus the square root of 3 over 2 minus 1. If you try to plug that into your calculator, it's going to give you an answer that's just a decimal approximation. But remember, our table actually has a square root. So what you want to do is try to simplify this by hand. So we have a fraction. In this fraction, the denominator is 2. And to subtract fractions, I need a common denominator. So instead of making this a 1, I'm going to make it 2 over 2. I'm going to multiply by 2 over 2 to get it the same denominator. So now I have sine of theta equals 2 plus the square root of 3 over 2 minus 2 over 2. Now I'm going to subtract. So now sine of theta is 2 plus the square root of 3, and I can subtract the numerators and keep the denominators the same. Notice this becomes 2 minus 2, so those cancel. So I get sine of theta equals the square root of 3 over 2, and now this is an easy problem. So now what we're wondering is, where is sine of theta square root of 3 over 2? If you look at your handy dandy little table on the first page of your notes, that happens the first time when theta is 60 degrees. That's our reference angle. So I know it at least happens right here at 60 degrees. This is positive. So where else is sine positive? I'm going to write my little all students take calculus. Well, it's also positive right here. So this is where sine is positive. So it happens here and it happens here. To figure out what that other angle is, I take 180 and I'm going to subtract 60, because I know it's 60 away, which is 120. So my final answer, theta is 60 degrees or 120 degrees. So here's a few homework problems. Let me know if you want me to do a video on any other problems.